Okay, I think we're good to go. Okay, so hi everyone. Because we had to cancel Friday's section, we're gonna try and do this in a video, and I will do my best to make sure everything is as clear as possible, though this is my first time working via video. Okay, so today what we're gonna be talking about is double marginalization, and it's the classic example of a principal agent problem, wherein someone hires someone to work for them, but their incentives are not aligned. So this first true-false question, I'm going to leave it to the end once we're done with this page here. Before we get back to that, it should become clear to you once you understand how central wholesaler is deciding to find their prices and all that. So we'll jump right into the math question. So we know that Johnny Lobster Farm sells lobsters to a central wholesaler distributor who then sells lobsters to consumers in an isolated island. Okay, so what's important is that Johnny's Lobster Farm, which I will call the principal, the person who is preparing all of this, has a constant marginal cost of $1 for each lobster and no fixed cost. So central wholesaler is a monopoly and has no other costs, important here, no other costs, except the cost of the lobsters that are charged by the fishermen, which is $2 in this case. Demand in the market is P equals to 11 minus 0.01 Q. Okay, so Johnny's Lobster Farm is charging $2, which I've mentioned before. We don't know if that's optimal for Johnny. We'll talk about that later. But if central wholesaler profit maximizes, then what are the price and quantity? So remember when we're talking about profit maximization, let me get a normal font going here. Oops, computer's a little bit slow. Okay, I'll keep talking. So what we're trying to find now is profit maximizing point. And remember, whenever we're talking about profit maximization, we want it to be MR equals to MC, okay? Next step, how do we find MR? So since our demand, I don't know why the font is doing that, but try to follow. I'll just make it blue as well here. I'll make it red, okay, all of it red. Okay, so demand is given by, up here, okay, demand is given by P is equals to 11 minus 0.01 Q. So we know now that your MR equation is given by P equals to 11 minus 0.02 Q. So what you do is just to multiply the coefficient of Q by 2. And that's how I got 0.02 Q here. Remember, an important thing is that your demand equation has to always be in the P equals to something Q format. So you can't say, you can't have it as an example. Let me just write it here. I'm going to delete it in a second. But you can't do it as 0.01 Q equals to 11 minus P. And then you do Q equals to, what is this? 1100 minus 100P. And therefore my MR is given as Q equals to 110 minus 200P. Okay, this does not make sense. Because your MR has to equals to MC, right? As we have over here. But this means that because your MC is a dollar value, it has to be a number of some sort. In this case, it's $2, but it could be 5, it could be 10. So which means that your MR also has to be a dollar value. In this case, you've created a situation where your MR is referring to a Q, to a quantity, which doesn't make sense. Okay, so this is what you should not do. I'm going to cross it out for effect. Okay, and I'm going to delete it. Okay, so back to our calculations. What is that? I don't need that anymore. Okay, so now we have our MR equation. We're going to put MR equals to MC. which is given by, which then should be almost second nature to you guys, equals to the MC of $2, which then gives us 11 minus 2 is equals to 0.02Q, which gives us 9, that's not 9, 9 equals to 0.02Q. So to get Q back to a whole, we multiply both sides by 50, and we get Q equals to 450. Okay, now when Q equals to 450, 450, P becomes, we remember in this case another important step, we're just going back on Monopoly. Remember that this Q equals to 450 has to go back into the demand equation, not the MR equation. It would not make sense. We'll see it in a graphical format towards in the middle of this on the second page. But right now, remember that it goes back to your demand equation. So this becomes P equals 11 minus 0.01 multiplied by 450, which gives us P equals to 11 minus 4.5, which gives us P equals to 6.5 or 650. Okay, so here we have the answers. We have P equals to 650 is our profit maximizing point for the wholesaler outside, and Q equals to 450 as well. That's the point. And these are going to be very important when we start sketching our graph. Okay, let's move on to profits for each entity. Oh, did not mean to do that. Okay. So profits, very easy, except when it's not red. Okay. Profits is equals to revenue minus costs, which is equals to price times quantity minus price times marginal cost. Okay, does this make sense? Okay, I just asked a question to a video, but okay, so this should make sense to you. Okay, my bad. This should be Q times MC. Okay, so we can simplify this to Q times price that you're selling at minus the marginal cost. Okay, I don't know why it's doing that. Okay, so it's the total quantity that are being sold multiplied by the difference between the price and the cost of each item. So we can very quickly move into solving this, knowing that we know our P and Qs now. We know our P and Qs, we know the marginal cost for both entities. So we can go ahead and start solving. So for Johnny's lobster farm, assuming that they only, for what they're buying from, what they're selling to the wholesaler, we see, why is it doing this? Okay, we see that profits will be equals to the quantity, which is 450 in this case, multiplied by what they're selling, what they're charging central wholesaler. Okay, so you see here, Johnny Lobster Farm is charging $2 to central wholesaler. So they're charging $2, but they incur a constant marginal cost of $1 for each lobster. Okay, so we're going to subtract $1. That gives us 450 times 1, which gives us $450 in profit altogether. Now for the central wholesaler, okay, so profits will be equals to, again, Q, we're going back to this equation over here, quantity multiplied by what they're charging, which we got from here is 650. Okay, 650 minus what they're getting, what it costs them to get for each lobster, which is here again $2. Okay, their marginal cost is $2. So minus 2, we get 450 multiplied by 450, which will give us, which I have here, $2,025 in profits. Okay, so I'm gonna box these up. You're gonna see this document on your Blackboard. I'll also mention that in the announcement I send out. Hope this works. Okay, so now, we have the profits for both companies, and you can see there's a huge difference, right? So back to this question. In double marginalization, the downstream closer to consumer, which in this case would be central wholesaler, because they're the ones who sell it to the consumers here. If you read this part, central wholesaler who then sells lobsters to consumers. Okay, it's trying to maximize the combined profits for both the upstream and downstream firms. So we know they're trying to maximize their own profits, which is the downstream firm profits. But what about for the upstream? Okay, the question is, in our calculation so far, did we do anything that had to do with the way with Johnny's profits? We didn't, because as you can see, the only information we got from Johnny is just the price that they paid us, which is this $2, the marginal cost to central wholesaler. In this case, we're not trying to profit maximize for Johnny. We're trying to profit maximize only for the central wholesaler. So the central wholesaler really doesn't care too much about how well the upstream is doing, how well Johnny's lobster farm is doing. So in this case, we would have to say a resounding false. Okay, a resounding with a box kind of false. Okay, so let's move on and see what other problems this principal agent problem could show us. And the next question says, draw a graph showing a solution to the previous problem. You've seen this 1,000 times. I'm going to do it really quickly on my graph sketcher. So we know that we need to graph. The first thing you want to graph is this. Okay, I'm going to bold and underline it. Okay, the first thing you want to draw is this. So question is, when Q equals to 0, what is P? P would be 11, right? When this whole thing is 0, P would be 11. So let's start from 11. Okay. Price equals 11. And we know that for this equation, okay, so we know it's P, we're going to mark it there. So we know now, what about when P equals to 0? Okay, when P equals to 0, and do it very, very quickly here, ignore this question. Okay, so the formula is P equals to 11 minus 0.01 cubed. So when P becomes 0, we have 0 equals to 11 minus 0.01 cubed. 11 equals to 0.01 cubed. And we have Q is equals to, we have to multiply by 100. So we have 1100. So Q would be 1100. So let's go ahead and sketch that. That was not where I meant to go. Okay. So from 11 to 1100 on the quantity side. Okay. I do not like it being red. Let's get it back to black. And let's get it back to normal solid line. Okay, excellent. So I'm just going to label this real quick so it's clear. We have this demand curve, which is given by P equals to 11 minus 0.01 Q. Okay, let's move on. What else do we have to sketch when we're talking about a monopoly? Okay, the second step we did up here was to immediately find our MR equation. So following I'm not going to do the calculations because I have done them already, but we're just going to follow the same logic as to how to plot this graph as we did with the demand curve. So I'll go ahead and start plotting. We know that when Q equals to 0, it's still at 11. So I'm going to start from 11 again. And then, but what happens here? If you do your calculations, you would find that it would stop at 550. Another good trick to figure out how to get this is all you have to do is half whatever the demand curve cuts, wherever the demand curve cuts the x-axis. So in this case, you can see I'm at 550 for the MR curve and 1100 for the demand curve. So that's just a quick way of getting it. But again, to avoid confusion, let's go ahead and label this. The MR curve would be given by P equals, or rather MR equals to 11 minus 0.02 Q. Okay, excellent. Now, other pieces of information we have. What are the MCs, the marginal costs for each company? I want to plot it for both. So even though, yeah, okay, let's just plot it for both. So Johnny's Lobster Farm has a marginal cost of $1. So let's plot that real quick. Okay, and as usual, let's label it so we're not confused. MC for Johnny. Okay. Just move this to the corner. Remember, this is MC for John, even though it's on the side. Move this to the middle. Okay. So next, going back, what is our central wholesaler's marginal cost? $2. We've established that. Again, simple matter of building this and labeling it. MC for central wholesaler. Awesome. And we can move it to the side as well. Okay. So let's just run through what we did mathematically in terms of a graphical standpoint. So for this line, you know, for right now, we're not going to talk about Johnny very much. So I am going to hide him very quickly. Okay, so there he goes. Hope I can find him later. Okay, now we did, at this point, MR equals to MC. That was our third step, or second step. So we know that it has to be a point somewhere here, right? Where MR equals to MC is exactly at this point, and similar to our calculations, you see that it hits 450, okay? Now that we know we want to sell 450, remember my caution that we always have to go back to the demand curve? We go from here to find the price that we should sell at by going back to the demand curve, okay? And what does this tell us that the price should be? Exactly 650. Okay, just gonna click out of there so you can see what's going on. So we now have a price of 650 and a quantity of 450. That's exactly what we found in the first part of page 1. So this part. Okay. I'm not going to label the numbers, but this is 650, this is 450. Okay, now we got to label the, I don't like this color at all. It's the blue for, no, let's find the costs, or the profits, my bad. The profits for central wholesaler, okay? And you can see that if I'm selling 450, okay, 450 at 650, this area is gonna be my revenue, okay? And very easily we can also tell that if I mark it at a different, nope, that's not what I want to do. Okay, if we decide to mark it in a different color this time, you can see that this will be the cost. This will be the cost of selling 450 units for the central wholesaler. And very simply, whatever's remaining of the blue becomes your profit right here. Okay, this area on top. So the blue, again, is your profits for the central wholesaler. Let me see if I can label it. Okay, I can't. Okay, but if you're following this tutorial, you should understand where I'm going. Now we have a second part of this question, which is for Johnny's Lobster Farm. What is their profit? Let's see. So we know, we just know that they have again, their constant marginal cost. Can I find it? No, I can't. No. Okay, I'm just gonna try it again. Okay, let's just try it again. Okay, I think I deleted it on the first run. Labeling it, let's see, for Johnny. Okay. So marginal cost for Johnny is $1, and he's charging $2 regardless. Okay, to central wholesaler, which is why their MT is constant. So this space, you can tell, is the difference between what they're charging, which is $2, and what they cost them, $1. And we can easily see if we pick a different color now. Wait, I should select that. Pick a new color. Let's say green. Okay, that this area the green area becomes the profits for Johnny. Okay, because you're only selling 450 lobsters at $2 a piece with a $1 marginal cost. Okay, so this green area becomes the profits for Johnny. Okay, so this settles the whole of the graphical question, and if you label these accordingly, you should be good to go. Okay, let me delete this. Okay. So at the quantities solved for, what are MR and MC for central wholesaler? It's not really a difficult question here. So remember, if you will, remember that we put MR equals to MC, okay? And so therefore, we were given that MC for a central wholesaler, which is what this question is asking, is $2, okay? Therefore, we can say that MR was also $2, because this was exactly what we solved for. We solved for MR equals to MC for the central wholesaler to find a profit maximizing point. So the numbers that they're asking for here will be $2 for MC and $2 for MR. So not much to do there. Okay, now more of understanding how the principal agent problem works. So Johnny's Lobster Farm is thinking of raising the price to $3. So they know that for some reason they did the math and they know central wholesaler is maximizing at $6.50, and so they're saying, oh, if I add $1, they're still gonna make. If they're still gonna sell at $6.50, they're not gonna lose too much money. Is that right? Okay, so the question tells you it's not. So what exactly is wrong? We have to go back to this graph. Okay, so now let's say we clean up this place. Okay, I'm going to take the long route to show you what's going on. So now we know the question is saying, what if they raise the price to $3, which means the marginal cost for the central wholesaler becomes $3. And we can quickly plot that. Okay. MC for central wholesaler. Okay. Okay, now it's at $3. Let me change this to new MC so we're not confused for people who are just joining, who decided to watch this from the middle of the video for some reason. I don't know why you would do that. But, okay, let's just run through everything again. Now you see that we have a new and a different intersection between MR and MC. When we're doing monopoly calculation, again, we're looking for the point where MR equals to MC. So, a quick look at this without doing any math. We can see that the optimizing quantity is 400, right? Extend it beyond up to the demand curve, as I said before, and we'll see that the new profit maximizing price is $7. Okay? And back to our labeling thing. So if we label everything the same way we did before, not quite in the same colors because it's just blue, red, and green. So we can see that for central wholesaler, their revenues are this much. Oops, we'll do that again. Boom, boom, and boom. Okay, this is their revenue. Their costs, oops, their cost has changed, definitely. So if we mark out their cost, it's from $3 for 450. So no, 400 lobsters is what I meant to say. Okay. So you see the revenue is this much. I don't know the math. I could put it together real quick, but I'll leave that up to you. So you see the profit has changed. Okay, actually let's just do it right now. 7 minus 3 times 400. The profit is now $1,600 instead of what we calculated of 2025. Okay, so we change it's decreased for them. Okay, and the new profit margin for Johnny, which is exactly what he wanted to do, what he wanted to gain out of this changing of the price, is this color. If we go back and to our green, Johnny's profit would look like this. Okay, so it's at $3 for 400 items with a $1 marginal cost. Okay, so again, just to reiterate, the blue here is the profits that belong to central wholesaler in this new profit maximizing condition where Johnny has raised the price to 3. Johnny's profits will look like the green area, and the red will basically right now only show what the cost is for Johnny for selling 400 items. So you see, there are a lot of things that have changed. What you need to take away from this is to realize that there are a ton of things that have changed. We're no longer at $450 and $650. We're at $407. So it's not as simple as Johnny thinks. Okay, so what I would say here is that central wholesaler will want to profit maximize, which is what we did before, right? So profit maximizing will result in changing the Q, which we have shown you in here. Changing the Q. So Johnny has to consider how Q and P will change. It's not as simple as just because there are profits. It doesn't mean that central wholesaler won't react to the price change. Okay? Okay, let's make this red. So it's important that you understand this to understand double marginalization. So you see, Johnny actually has a say in how much, Johnny actually has a potential say in how much central wholesaler is willing to sell. And that affects his own profits, his own revenues, and his total costs as well. Okay, so let's move on. If Johnny charges a higher price, which we've discovered here, the MR equation and graph for central wholesaler will change. So will this change? Let's go back to here. So remember when I went back and did it for the new MC for central wholesaler, what did I change on this graph? Literally the only thing that I moved that was in a solid line was this line, the new MC for central wholesaler. I moved it up from 2 to 3, if you remember. So I did not move the demand curve because it has never changed, and because the demand curve has never changed, I had never changed the MR curve. So the MR curve is still the same way you would derive an MR curve from a demand curve. So in this case, the MR equation / graph does not change. So bold in a box like before. Okay. So if Johnny charges, this hint helps you with this question. If Johnny charges a higher price, the MC equation graph for central wholesaler will change. Well, did that happen? Yes. So this is the only thing I've changed. The MC, I moved it up from $2 to $3. So this is true. Very simple. Okay. So if central wholesaler still charges $6.50 and sells 450 lobsters, how do MR and MC relate? Okay. We know that we can go back to this graph, or you could do it mathematically, but because I'm teaching you via video, it might be easier to do a graphical representation. Okay, so if we want to talk about the same numbers, 650 and 450, right? $6.50 and 450 lobsters. We can quickly just draw the lines and show where they were before. Okay, it was right here. So remember, it was at $2 at this point. Okay, and we'll draw this right across. Okay, so some of you might be confused about why I did this instead of going back up to the demand curve and then finding it again. Okay, we don't have to do that because the question right now we're asking is, how do MR and MC relate? So these dotted lines really just tell you what the central wholesaler's MR is when they sell 450 lobsters. Okay, and because the MR curve never changed, that marginal revenue at 450 will still be 2. Okay, will still be $2. So this is the MR. Okay, I'm just going to label it for clarity's sake. MR at Q equals 450. Okay, so it's not anything, we're not doing any calculations for monopoly, we're just purely from the MR curve trying to find out what the MR is for a central wholesaler if they decide to sell at 450. Okay, so marginal cost, does it change? It's now at $3, right? In the new situation, we've moved it up to $3. So which answer is it? Is $3 of MC versus $2 of MR. Clearly, we can see that your MC is higher than your MR. Okay, bold and box again. And this makes sense. So they should produce fewer units and raise the price. Is that what our diagram tells us? Yes. So they should be selling at 400. So yes, that's a decrease in units. And they should be selling at $7 instead of $6.50. So that is an increase in price. Okay, so this part is true. So we know that that's the answer. So how this last part, and we're almost at the end of my first time teaching via video, which is fun. Is very simply asking you how you would decide if Johnny would charge $3 or $2. Remember that back on the first page, we gave a disclaimer, which may not be optimal for Johnny. Okay, when we're doing this calculation, we did not know and we did not need to know whether $2 was optimal for Johnny's lobster farm. Okay, but if we wanted to know whether it was optimal or to compare two different prices, the first thing we would do is to calculate the price to consumers and quantity if central wholesaler profit maximizes with an MC of 2. Same thing to do, but with an MC of 3. And once you have these two things, what are you comparing here? What would you like to compare? Okay, so this is the comparison and this is the decision-making rule, so to speak. So it's easy to see. What Johnny is trying to do is to maximize their profits as well. So if they're comparing between charging $3 or charging $2, you would want to compare, in bold, compare the profits for Johnny's lobster farm in both cases. Okay, very easy. Because if one has a lowering profit, then what? Johnny would not decide to do that. Okay, and I just gave you the answer for this, but if profits at $3 are higher than, okay, and we should put the profits for at 3. Okay, let's do this. Profits for Johnny at $3 are higher than profits for Johnny at $2. Then Johnny should go ahead and charge $3 because it does them better. Although there are a bunch of considerations about, say central wholesaler being unhappy if they have a contract or anything, but that's not what we're considering here. Right now we're just doing the math. We're doing a ceteris paribus world, and you should not have to worry about that. So, yep, that's all I have for you on this worksheet. If you have any questions, feel free to email me. The wonderful thing about teaching on the video is that you get to type out things, and this is my man ID. You can either reach out to me with any questions and send your questions to me, or just hit me up and we can arrange a time for me to explain this to you in greater detail. Thank you very much for watching, and I hope you have a great day.